Okay, I got the feedback that there is no audio. Um, I was giving a recap on everything that we did from the beginning last week. So here's a recap again. Because the audio was gone, I was recapping everything that we have done. This is the architecture that we're trying to deploy, and so far we have most of it already deployed. We have set up our services in the AWS region EU Central 1. You can see it here, EU Central 1. You may have picked a different region for yours, but just make sure you're working in the same region for everything you're deploying so that they can find each other basically. We have our VPC, our virtual private cloud, set up with our IP range, the CIDR block of IP ranges that we want to make available in our environment. We configured it to use 2 zones to deploy our subnets. We have 4 subnets deployed, 2 public subnets and 2 private subnets. The difference in those subnets is how open they are to access basically. And configuring the subnets to use specific block of IP ranges so that you make IP addresses available for the services you deploy there. We set up NAT gateway, S3 gateway, and also configured our security groups last week. The last thing we did last week was to deploy our web server. That's the EC2 instance. And we'll be picking up from there. So we stopped here. That's the deploy compute EC2, and we'll continue with our goal to the end. So now we're going to the next, administering our web server. There are different ways you can administer your web server, yes, but the I would say best practice is just to do it with the managed service. This is SSM is AWS Systems Manager. You use the session manager to log into your EC2 instance instead of trying to expose it to SSH into it from your local environment. So you don't have to, be using SSH to connect. You can go straight into your EC2 instance in the console environment, and that is secure. So here we would be starting with our web server instance that we already have. Let's look at it here. I think this is, let me have more space for you to see. So it's selected here, and this is the, block where you see extra details on your web server, everything that you have here. So here you can see, like they mentioned, it has a private IP address. It doesn't have a public IP address. And if you want to expose that publicly, there are more things we will still be doing, but we'll be setting up load balancer in front of our EC2 instance, and that would have its own public stuff. I don't think we have any reason to assign public IP address to our instance directly here, but by default, it doesn't come with a public address. Next thing we'll be doing is we'll connect with to our EC2 instance with the session manager. I said there are different ways you can connect, but this is how we'll be connecting to it. So it's selected, and then we click connect here. Connect. You can see all the ways to connect. We're not using EC2 instance connect. We are using session manager. You can explore all the other ones that you want to do, but okay. You can explore all the other ones that you want to do, but it can get more complicated if you're not careful. But using any of these options, you can lock sessions. There is a reason let me check my EC2 instance is okay. Yeah, it's in a correct state, and now I should be able to connect to it. I guess it wasn't fully ready yet, but you can explore all the other options and the instructions to connect with them, But using session manager is just to click connect and then we log into the system environment. So this looks very much like what you see in your terminal. Yes. And would be exploring that. So this is what they want us to run. We'll look through it. I mean, okay, yeah, this is just testing connections. So let's see. I've copied it here. I'm going to paste it. These are commands, Linux commands that if you want to get more info of, you have to look it up. But essentially, you're trying to get your configurations, like your own environments, basically your server, your instance, the first one. And the second one is actually calling this checkip.amazonaws.com, and that's the public IP address that's being deployed here, that's being printed out here. So we have been able to connect to our EC2 instance, and we can run things from inside our EC2 instance. In this, all accessing it from the console. So next thing for us would be to deploy our load balancer. This was just showing you how to access your instance, how to run things within your instance. I could start a whole service, deploy something, clone a whole Git repo, and run all the things that you run in your terminal in this environment using Session Manager. And we can go on with our load balancer. So to deploy our load balancer, we would have to, of course, configure some things. But before that, I want to just quickly touch briefly on what load balancing does. It does exactly what it says, balancing the load across multiple instances. So right now we have only one instance, and putting a load balancer in front would only direct all the traffic to that single instance. But if you put a load balancer in front of more than one instance, it's going to distribute the traffic based on how you have configured it. Maybe you want it to evenly distribute the traffic, or you want it to probably by the request, maybe you want all requests to a root go to this instance, that one's go to, depending on how you want it to distribute the load, it balances it out the way you want it to. That's the main function of a load balancer. But you can also use it as a way to abstract, like not allow direct connection to your instance by exposing just your load balancer and keeping your servers private, allowing only connections from your load balancer to the server and not from any other location. Now we will be working with the application load balancer. AWS has more than one type of load balancer. You will see the network load balancer. They balance load at different levels of your OSI model. Think application load balancer balances distributes traffic on the level 7, and network load balancer handles traffic on level 4 of your OSI model. So we're going to the EC2 service. Here we're already in EC2 service basically, and if you go down, you see load balancing here, load balancing. So we're going to load balancers. You see your load balancer, your target groups. From the navigation, click load balancers. We start with creating our load balancer, and then yes, so this is what I was explaining now, that it operates at the application layer. That's the level 7 of your OSI model, and network load balancer functions at the network layer, which is level 4. Yeah, I think, yeah, you can look it up. It's OSI model, and we'll go with our application load balancer. So let's get started. Create a load balancer. There's the application load balancer, network load balancer, gateway load balancer. When you're on this page, you can take your time to read about every one of them, but we'll be working with the application load balancer. So I'll be going with this, create application load balancer. Let's see the exact configurations they want us to set up for our application load balancer. So the load balancer name is going to be web server load balancer. We're going to make it internet facing. So basically it's public. And we're using IPv4 IP addresses. There's IPv4, there's IPv6. We're using IPv4, that's the normal one that you see. And we'll be using the public subnets and our project VPC that we created. So the only thing I'm copying here is this. So here's our web server load balancer. It's internet facing. Remember I said it will be public. If you put it as internal, it will be private and you won't be able to access it from the internet. We are using IPv4 and our network mapping. We need to pick our VPC that we created. That's the project VPC. We're going to be distributing across both zones. Availability zone EU Central 1A and EU Central 1B. These are the ones that are available in our VPC here. And we are using the public. Let me confirm. We're using the public. Yeah, public. We're using the public availability, public subnets in our availability zones. So public subnet 1 and public subnet 2. Just to confirm again, yes. And then we can go on with our security group. So remember we created web server security group and load balancer security group. Now we'll be attaching the load balancer security group to this. Now the beauty is that when we have multiple things and we can just easily attach security group to a service and it would have all the access or the denials that we put in the security group. All we want this access from this IP address, from this server, from this service. You can just attach it and that AWS service gets all the access you've configured in that security group. So load balancer security group. I'm removing this because we are only using this load balancer security group and we are using the default HTTP and port 80 for our listeners, and then we use that for we use that to create a target group also. So this is the default HTTP 80. We create a target group. That's the port on which we want to forward to this target group. So our target type is instances. We're going to be using our EC2 instances to balance the load. So you can put an application load balancer in front of other kind of targets, not only your servers. You can balance it across your Lambda function. You can put other load balancers for different, like maybe you are layering load balancers. You can arrange it like that. So here's our instance type, target group name. Let's go back to confirm the configurations we're going to be using for our target group. So this is the configuration for our target group. We are using instances. Remember, this is our target group name, and we are also going to be using protocol HTTP on port 80. And we'll come back for the rest. Let's get started. So our target group name is going to be web server target group. We're using HTTP on port 80. Our IP address type is IPv4. Remember, we're working with IPv4. Our VPC is project VPC only. And then protocol version, I would say we're using HTTP 1, but let's confirm it. Yes, HTTP 1. And our health check protocol is also HTTP on the root part. So that in itself, it's up to you basically, but this is the part on which your load balancer is going to be checking to see if your target is available to receive traffic. So make sure your health check part is something that actually correctly represents your service or whatever it is you're deploying, to check if it's available to receive traffic. If it's not able to get a good response from it on this part, it's going to always mark it as down or not reachable. And yes, we're adding tags. Add new tag, name, and web server target group as the name. So here name target group, and we can go next. So you select the instances that you want to register as targets um for your load balancer. We have only one basically. You put it here. But if you had multiple instances, you can select the ones that you want to attach in your target group. And as a group is going to be receiving requests from the load balancer. Ports for the selected instances is post 80. Let's confirm everything here again as we go. Yes, we select our web server and then we continue with it. So include as pending below. Let's see, review targets. Okay, these are our targets, and then we can create our target group. So we have created our web server target group. We are in the middle of creating our load balancer, and we had to come and create a target group that we want to attach to our load balancer. So we'll be going back to that to continue from where we stopped. Now we can go back and we'll see our web server target group available for us to attach in our load balancer that we are creating. Here we click this again, and yes, we have it here. So we've attached this. We don't need to add tags for listener. Are there any other configurations that we want to add here? We've created our target group, we've refreshed the button, and we've selected it. So we are leaving the remaining settings as the default. That's what is advised here. And then we create a load balancer. The thing is, you can always experiment in the way you want to create it. But if you want to have the same results that we are getting, then we are going to be doing everything the same way. Yes. So we're not adding all the extra web application firewall or CloudFront or any of those things. They also cost money depending on how you want to use them. So if you're going to try adding them, check the costs on the AWS free tier, if you have free ones or not. We're creating our load balancer. Successfully created load balancer, web server load balancer. Hey, so we're ready to go. Status provisioning. Let's see what we have. So we have our listeners and our rules. We have network mapping, everything. We're all in this VPC. We have 2 availability zones. In the resource map, you can see what is happening here. So we have a listener on our load balancer protocol HTTP on port 80. That's where it's listening on. And we have only one rule that's forwarding everything that comes here to the target group. The target group happens to be our web server target group, and the targets in our group is just one instance right now. So yeah, it says target registration is in progress. So right now, if we're running things, nothing will be working well yet because it's still connecting well to each other and all. But let's see. It's still provisioning. You can explore everything that you have here to see what you have. You have security group, our load balancer security group. This is just metrics that you expect to see. You can see the errors, how many requests, how long it's taking to answer what you're doing. And reality is, when you have a real environment that you are deploying in, you always want to have some form of load balancing. It can be different levels that you are working with. Maybe you have load balancer for your Kubernetes cluster, or you have application load balancer, network load balancer. If you want to have some way to handle multiple traffic, that sounds wrong, but you get what I mean. Like, You don't want single points of failure in your different setups. You don't want that. These are the things that we come to the cloud for, to be able to, automatically scale, automatically handle things. When one server is down, your load balancer is able to see like, oh, the health check is not passing. I want to be sending requests there. I'll be diverting this request to the other server and all. So yes, there is a lot of things to explore with the services we're trying out and what you want to implement. Dig deep, you'll find something that works, or you can make something that works in the cloud. Now we can get going. We're gonna test our web server. Testing our web server. Before we can access it, we need to wait for it to be fully provisioned, and our target group has to be healthy. Right now, when I checked, it was still provisioning, so I don't know what it's going to be. We've been talking. Let's see if something will be different now. It's active. 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 Okay. It's active. Let's go back to the home page of our load balancers. It's active. Let's see what we have here. It's active. Listeners and rules. Okay, our target group. Let me see. Our target group is healthy. You can see healthy 1 on healthy 0. So it has checked and tested from our server. Our server is shown as healthy. That means the health check is passing. So yeah, nice stuff we have here. Now we're gonna be testing it. Navigate to the listeners and rules tab, click on the web server target group link. We verified that there's a healthy target there, and now we're going to go to the public URL of our load balancer. Remember, our server is private. It's in our private subnet. It's not accessible. But our load balancer is in the public subnet. It has public IP address. It's accessible from the internet. And when we access our load balancer, behind the scene is forwarding the request to our server, and our load balancer is able to access the server, but we can't. So we're talking with our load balancer, and it's going to be doing everything. And here we're going to our load balancer. Here is, let me see the details. When you check, you should see the DNS name. Can you see here? The DNS name, bottom right. And I copy it. That's what I'm going to be using. So here we go. I'm coming. I think I'm meant to put, okay, HTTPS. I'll check again. Yeah. Also, yeah. It automatically puts HTTPS. We don't want HTTPS. We only opened port 80 HTTP protocol, remember? Okay. Alright. Our server is giving us the answer that we want. So we have been able to deploy our web server in AWS. I mean, it's using HTTP. It's really lightweight and not so able to handle anything heavy right now, but it's working, and that's what matters. So congratulations. We can now do everything else that we needed to do. Our S3 that we want to connect, and then we will try having a full auto-scaling group of web servers that automatically can arrange themselves based on how much requests you are getting. So you don't have to deploy 10 servers from the beginning. You can only have your one server. But you'll still sleep well at night knowing that when you are doing your Valentine's sales in the next 2 weeks on your websites that you have, and then you are getting millions of requests compared to your 10 requests, your setup would be able to handle that by automatically scaling, adding more servers to handle the anticipated requests, or depending on your rules, maybe reactively handle the request. Here we have our next step being to use S3. Yeah, but before that, let's see what they say we should do. Connection tester app, scroll down to API test and check some of the example API. Let's see. Where's our app? So it's EC2 connection tester. There's an API. Let's call it. Okay. Let's go back. Random data API. Random data. So yes, it works. It works perfectly. And yeah, that's interesting. But before we are able to do anything with S3, we need to set it up. We've not yet set up our S3 connection, so we'll be back here. But at least we have one major win already. It's working. Now going with our storage. Here we are having S3 service. We're going to create a bucket and we are going to name it something unique. One thing to remember. I will always tell you things to remember. Don't be angry with me, but yeah, they're just important things to remember. So we're going to be looking for S3 here. What I want to tell you is when you are creating your S3 bucket, it's not only necessary for it to be unique in your own account, it is necessary for it to be unique worldwide. Yes, it's a globally unique name. You see what I said? Your bucket name must be unique within the global namespace. So remember that. Bucket name, I'm going to say ACP QWERTY. I'm not sure. Does it exist? I don't know. We'll find out. So we're naming it. And I expect that we're not setting any difficult rules around this bucket. Yes. I think we may be having tags, but let me check. We'll leave the other settings as default. We're not adding any tags, and then we create the bucket. Okay. So let's go back to our S3 bucket, and we're leaving everything as default. You can go through them, read them. It's really, really explanatory. And I like the AWS console because beside every kind of title or something, you see this info key that you can press and read up about what that particular thing is about. So yes, we're leaving it default, creating our bucket. And this is our ACP QWERTY bucket, very empty. We're going to be adding files to our bucket. Look at it as just a storage space. You can have many buckets, like folders. Put in files there, any kind of file you want to put. And we'll download the required files, unzip and upload the zip. Yes, we're going to be having, I've unzipped it. There's nothing much there. Let me show you what you have there. There it is. Just a file, another test file. There's a picture. Okay, this cat is the employee of the month. Interesting. And there is, do not read me. Okay, so this is the entire folder that they told us to get. And I will be having to upload that into the bucket, but I'm trying to find the right place to keep that. ACP criteria here. I think we should be able to drag and drop. I want to try that. Yeah. Okay. That was easy. You can also click that upload button and select the files and put them here. But I just use drag and drop and we have it. So here we have, this is everything that I want to add, and I would upload them. I don't think there's anything else I want to add. Upload. So you can find them on the internet now. Everything is there. Employee of the month, .png, which is a cat in reality. Yeah, everything is there. Next thing they want us to do is to go back to our website that we have deployed. We put our bucket's name, and then we'll check it to make sure that it's there. So where's our bucket's name? ACP QWERTY. ACP QWERTY. Let me close this place so we go back. This is it, ACP QWERTY. When you go to your bucket, you can see it here also, ACP QWERTY. That's the name. Use your own name. Don't use my own name if you've not. Use your own name. So here we're going to be entering. Let me make it bigger so we can all see it. We're going to be entering the name of the bucket, ACP QWERTY, and we're going to browse. Aha, there is, no, let me go back. That was about access key, but also I see that we have the wrong region. We're using EU Central, or I'm using EU Central. I don't know what you're using, but yes, I'm using EU Central one, and the error is about permission. So it says error executing list objects on this particular networking in AWS. I actually changed the client error gets 404 not found, no such buckets. This preferred bucket does not exist. I had fixed that actually. Go back. The bucket's name should be this, ACP QWERTY, and this should be EU Central 1. Browse. Aha, so the error now is actually about access denied. So it's, let me explain it. Let me explain it. So error executing this object. This is an action in AWS on S3 objects, and it's saying it has this error while executing this action on this bucket, and we have an HTTP error that is from 403. 403 is access denied. So the user that we are in, that's, remember that we're going through a website now. We're going through a browser, and this browser is making requests to our load balancer, which is making requests to the it's forwarding, actually it's not making its own request, it's just forwarding it to our EC2 instance. That's our server. Our server is where this application, this website is running, and when we try to fetch things in the bucket, our server is going to be fetching from S3 and trying to show it to us in the browser. Now when they say access denied, this user web server instance profile is our web server that is trying to access the bucket, and it's saying our web server instance is not authorized to perform list buckets on the results, on our resource, the AWS resource, ACP QWERTY, that's the name of my bucket, because no identity-based policy. That's another thing, because there's identity-based policy, resource-based policy, but the policy of our EC2 instance profile, the role it's using, is not allowing it to perform this S3 list bucket action. It's not allowing it to perform S3 list, but that, I think we didn't give it permissions to perform all this S3 stuff. But the point is, we know the role is our web server instance profile role that does not have the permission to do anything on our buckets. And if we want to move past this, we need to fix that. I decided to explain this first because I know that there was something like that here. It said there's an error that occurred, and it says we don't have the permission. So we need to give the permission for it to work. How do you do that? We go to our IAM, that's the Identity Access Management. We go there. I think we can use this one. IAM. Okay. Our roles that we have here. This is our web server is instance profile. This is the one that is causing us headache. We're going to check it. Let's see what permissions it has. Let's see. So it has permission to do a lot of SSM things. Yeah. SSM messages, EC2 messages. But you can see there's nothing there about S3. So what I'm going to do is I'm going to attach a permission policy here that would give it additional things, additional access to S3. So I'm going to attach a policy. I'm going to pick an existing policy that exists. Let me see what we have with S3. There's S3 full access, there's S3 read-only access. Like these are AWS managed policies. You can try writing your own policy yourself. But I think I want to use the managed policy for S3 read-only access because we want this role to be able to get all the objects in S3, list all the objects in S3 and all of that. That depends on what your goal is. Usually you want to go with the least privileged access, only what you need. But this is an environment that is more relaxed. I don't have anything serious here. And as I'm building more things, I probably would want it to easily access different objects. You can specify the exact resource that you want it to work on. But here I am saying all the resources in my AWS environment. So any S3 stuff that it wants to do on any object and on any bucket that exists, it will allow it to do it. You can put here the exact bucket name you want to grant all this access to, or a list of bucket names or whatever. But whatever you're doing, just make sure it works for your environment. Try not to just be giving permissions as much as possible. So I'm going with this one. Yes, I'm going with that one. I'm going to add that permission. So it was attached to the role. Now you can see we have two policies attached to this role. The SSM managed instance core, and then we have the S3 read-only access. Read-only. Let's see if we still get this kind of error. Refresh. It worked. The error has been fixed. Now we are able to work with this. We can add more buckets, add more files, and we'll be able to see all the details because this application is able to work as expected. Our EC2 server, EC2 instance has access to the S3 buckets. Now, even though we granted this server the role that it's using permission to do things in S3 buckets, I could still put a barrier in my S3 bucket and say, I'm an S3 bucket and the only people that I want to see what I have inside my bucket is this person, only if you have this, only if you have that. So even if my role, my EC2 instance profile has all the permissions to access anything and the resource says, no, I'm not allowing you to see me, there's nothing it can do about that. Yeah, so understanding the different ways to grant permissions also matters, but we won't be digging deep into all those possibilities today. Next step for us would be, okay, we're explaining how to fix that, and yeah, we already walked through this. Next thing for us would be the auto scaling challenge that I mentioned we need to touch on. Currently we have one EC2 instance handling everything that we're working on. But instead of having only one EC2 instance, imagine we set it up that it could automatically scale to what is needed per time. So we have one EC2 instance, but if things get really busy and it needs to handle more requests and it's getting too crowded, too burdened with the request, it can easily add one more server to handle things and everything will still be working fine. That's what auto scaling would look like. And auto scaling, you want to also make sure that it's able to automatically scale down when it's not using as much services. Some people forget that they also need to scale down when they are less occupied. You want that. You want to be able to scale up, you want to be able to scale down. Yeah. So our goal is to make sure we don't have a single point of failure. When one server is not working, it's able to be replaced very easily. And this is where our challenge begins. We're going to use the auto scaling group, and we're going to try to make sure we don't look at any of the clues. I haven't done this workshop before, and I told you I wouldn't try to do it alone. So you may even have done it before you come to this call, but I haven't, and I am exploring this as if I was meeting it for the first time. Yes, remember that as we go. Okay, so we're going to EC2. This is the EC2 home right now. This is EC2 home right now. We have one EC2 instance running, and we have 0 auto scaling groups right now. I'm going to start with auto scaling groups. We're going to create our own auto scaling group. Create an auto scaling group. I want to follow the same naming convention that we have been using since. So I'll name it web server auto scaling group. You can also call it ASG. It's whatever you want to call it. Auto scaling group ASG. And we're using a launch template. So we don't have a launch template. We need to create a launch template. A launch template is basically saying use this template to create EC2 instances anytime you need to create EC2 instances. So I'm going to create a launch template somewhere here. I'm going to name it web server launch template. I don't know what to name it. Just say a test web server. Then write for AWS 101 workshop. Provide guidance. Yeah, let's go with that. So we don't have any launch templates that we want to use as our source, but it's kind of like as if you are copying from an existing template and you want to modify it. So that makes it easier for you. Application and OS images. So I'm going to use something from what I already have. This is what I used recently. You can also check currently in use. This is going to be the same for us right now because there's only stuff. This is the only one we have running. So I'm using this one. All the same configurations that I used there. The instance type, I want to include it in my launch template because I want to pick the one that is with the free tier. So free tier eligible, yes please. Keep a login. I'm going to not include it in launch templates, but you usually want to, because once you create your instance, you're not able to use the keep. You're not able to add keeper after. I think you have to, kind of duplicate, recreate to attach a keeper to it. So yeah, I'm not using keeper. We're not using it for this use case. We're not. And we're not including in launch template. We're including the subnet. All these ones we're including it because we want it to be in the subnet that we are using. So we're using private subnet. Let's see. So okay. What's going to happen is it's only going to add it to this private subnet. For now, I'm going to leave it out. and said not to include it. We are going to use the existing security group that we have, which is for our web server security group. Everything that we are deploying, even though we don't know when it's going to deploy, we want it to be in the same environment. And network interface 1. Okay, now let's start again and see everything that we've done so far. Our launch templates name, our version description done. We have our image, our machine image that we're going to be using the same kind of configurations we use for the existing one. And we have our instance type. We picked one that has the free tier eligibility. We're not using key pairs because, you can also use it if you want, but we're not using. We didn't use for the other one. You can set it up, but it's not necessary. If you want to be using SSH to connect to your instance or for other reasons, you would want to have your key pair. But right now we're not using it. Sorry. And I'm torn between whether we should include our subnet here or not. We're only able to include one subnet here. Let's leave the subnet out for now. We're only able to include one subnet in our we're only able to include one subnet. I want it to actually auto scale across the two subnets. Yeah, I want it to auto scale across the two subnets. Let's get started and see. So storage volumes, we're using this. Yeah, let's create our launch templates and see. Okay. So this is the launch template. I want to see what we have here before we use it. So we have storage, resource tags, advanced details. Yeah, it's not meeting my expectations, because there's still more that we need to configure, and I think we are going to look at closely our existing EC2 instance and use it as our guide for the template instead of just using what we want in our head. But I would modify these templates, or let me modify it. I'll modify it and change stuff. So I'll just write the same thing. Web server templates for workshop. There are things that we need to add to it. So we're going to leave this one open. I'll come here. There's our instance that I want to look at, our EC2 instance. Particularly, we also have some scripts that we said we're adding in the beginning, and we want to have it run every time we start our instance. Basically, when we're putting our instance. And that also needs to be configured in our templates, like, okay, add this to every instance that you are going to be creating. So we'll set that up, we get it running, and we get out of here quickly. So there's a security, networking. No, it's not meant to be in networking. I think it should be in details. Let me see. Or let me just go to the full page. Yes. So here, going down, I'm looking for our user data even more than anything else. We need that one. our user data. Status and alarms. No, definitely not in status and alarms. Let me see. It's meant to be here somewhere. User data, user data, user data. That's interesting. That the user data, I've seen it here. Yeah, I've seen it here. Monitoring, no. Security, no. Networking, no. It shouldn't be here. It's so annoying that I can't find the user data. But I guess I'll just go back and copy it from our instructions because it's there somewhere. So we have it in our deploy compute here. We have the user data that we added when we were deploying it. Yeah, all this code that we needed to put when deploying our EC2 instance. We also want to include that in the configuration of our launch templates. So copying it, and firstly let me find where that is and put it before I forget to add it again. Advanced details should be somewhere here. User data. So that's is there. Allow tags in metadata. All these ones we're not including it in our launch template. We're not including all these ones in our launch template. We want our instance profile to be in our launch template. We want it to always have this access, this role that we have attached to every of the EC2 instances that are being launched. We want that. And we want create new IAM profile. We're not creating a new IAM profile. Resource tags. Do we have tags for our EC2 instance? Let me see. I'm not sure we added tags. If we added tags, we should definitely add them here. So let's see. Yes, we add tags. So I'm going to add it too, so that every one of them is going to have it. Name. Yeah. And new volume. First network configuration. So we have private. We want this there. Yep. We've added one network interface. We need to add a second network interface. Private. Let's go with this top one and let's remove this one. Yeah. We've selected the security groups that we want to add everything in, and then we can go create this template version. This is what we want to use. Now that we have it, we can just verify that it has what we want it to be. Network interfaces, advanced detail. Yeah, we'll see that. Okay, now we have our auto scaling group. We have our launch. No, we have our launch template. We don't yet have our auto scaling group. We have several launch templates. We are using our latest one. No, I didn't want to press this. our latest one. That's what we are using. This is security group is going to be added to going next, and it's in the VPC project VPC. So these are the subnets that we wanted to work with. Private, these two subnets. Yeah. And balanced, best effort. So we go next. Load balancing, we have an existing load balancer. We're choosing from here. No VPC lattice. I think instead of explaining this whole zone active thing, let me just keep it off. But basically, it's saying like if an availability zone is not working well, like you should allow the load balancer to make that call to retarget your request towards other availability zones. But that's another configuration. So we're going to turn on this health checks for our auto scaling group, and we don't need health check for our volumes. That's for basically the attached storage to our EC2 instances. Just go next. Desired capacity is 1. How many do you want per time, like by default? And then the minimum desired capacity is 1. I'm changing the max desired capacity to say 3. That's the maximum. So having your maximum set assures you that even when things are getting out of hand and it starts increasing, it won't go beyond 3. No matter how the request choke, it's not going to go beyond 3. So you can set your max to also 1 to make sure that it's always going to be 1 no matter what happens. You can always change this later. We can always change it later. No scaling policies mean it's just going to be at the initial size. But if you want it to scale based on what is happening, you have to put your scaling policy. No scaling policy means it's not going to scale by itself automatically. So we have a target tracking policy. You can use different kind of metrics to scale your instances. Average CPU utilization is the easiest. You are saying, okay, you want 50. At 50%, it should add another instance, for instance. Add another instance, for instance. Add another server, for instance. You can use, say, the request, how many network bytes is going in or out of your stuff to be able to scale up or down. You can also use custom metrics that you want to track, particular metrics that you want to track. I'm keeping it as CPU utilization. I'm going to be using 75%. So when it reaches 75%, it will start trying to add another instance. And this, you don't want to add it, except if it's for your use case. When I say scaling in and scaling out, if you check this, after the storm has passed and okay, the requests have gone down, your CPU utilization is better, your CPU utilization might even be 10%, it's not going to scale back in. It's going to keep it at 3 or at 2 without reducing back. So you want to have this empty so that it will be able to scale in, scale out depending on how your CPU utilization is. Instance maintenance policy. No policy means anyhow goes. Anyhow goes. Read this to determine what works for you. I usually prefer launch before terminating. You want to add another instance because one is not working, or you want to whatever, the way as long things are moving around, this is what determines the behavior of your auto scaling group. It determines the kind of availability or requests that people can keep having regardless of what is auto scaling. Check it, know what works for you, and select it. And default capacity reservation. enable instant scaling protection. This one makes sure that it's not going to allow them to delete instances, or all these things are additional settings that we don't need actually. Notifications. Do you want notifications when there's an EC2 instance? Set it up here. Tags. I'm not going to set any tag. You can add your tag. And we're going to review and just create it. And with that, we have set it up such that we no longer have only one EC2 instance totally, whatever happens, no matter what. Now it's going to be able to adjust based on the CPU utilization. That's what I used for my target tracking. It's going to be tracking the our target group, like the target instances. Their CPU utilization is going to be monitoring it. Once it hits 75%, it's going to add another CPU instance. And when it falls below 75%, it's going to remove the extra ones and try and keep it at the desired capacity. If my desired capacity is 5, it's going to try to keep it at 5. And depending on CPU utilization, maybe it's too much CPU utilization, it's going to try and add more. And when it's less than, like when it's already back to normal, under 75%, it's going to try and bring it as close back to the desired capacity as possible. So there we have it. Updating capacity, we have 1 min, 3 max, and if you check your EC2 instances, we're going to have 1 desired capacity. Okay, I see that we have 1 because this one is not attached to our auto-scaling group. I'm going to have to remove it. But our auto-scaling group has only 1 that is creating for itself. And it's going to be managed by the auto-scaling group. This is the one that we created before. And we're going to have to remove it if you don't want to have 2 different ones running, because now we're going to be using our auto-scaling group alone. So I'm going to be removing this one. No, instance state, terminate state instance, terminate. And I think that brings us down to the end of our entire process. Don't forget to clean up. We're going to have to clean everything here. I won't be doing the cleanup on the call because we're way past our time. I wanted to make sure we finish this, but make sure to clean up. It's one of the most important part of using the cloud. Don't leave things running. Don't leave things running. It can take all your money away. And yes, after that, next week we will be looking at implementing this same setup, this same deployment programmatically. So we're going to be using CLI to try to run the commands. That is difficult, but it's worth it. And then also we would touch on using IAC, that's infrastructure as code, to deploy this whole environment. And once you have that infrastructure as code set up, you can always reuse it in different environments, or as you need to be, you can save it in your GitHub. And anytime you need to spin up a whole web server environment like this, you just deploy it and it's live. That's the beauty of IAC. Now when we delete all these things, if we want to put it up again, we have to be going to the console one after the other. But yes, I'll leave you to explore that. Thank you for joining me tonight. I wish you a nice evening. Bye bye.